Hi students, today we are going to learn about stepper motor. Okay. A stepper motor, it is a brushless DC motor in which the rotor rotates through a fixed angular step. Normally a motor has, we know, stator and rotor, right? We are having stator and rotor. So here in stepper motor also we are having stator and rotor. It rotates through a fixed angular step. Okay, so this is the main feature of stepper motor. That is, in stepper motor the rotor rotates in discrete angular intervals or steps. Okay, as I said, it has two parts, stator and rotor. Okay, so how we have to calculate the step angle for the stepper motor? So the formula for step angle is equal to 360 degree divided by NMR. Okay, normally a circle means we are having 360 degree. So here in motor we are having 360 degree divided by NMR. N means number of stator poles, MR means rotor poles. Okay, so here if we are considering the stepper motor as okay, these are stator and this is rotor. Okay, so how many stator poles are here? 1, 2, 3 and 4, and rotor faces 2, right? So here how we will calculate the step angle? 360 degree by number of stator poles are 1, 2, 3 and 4. So 4 into rotor poles are 2. So therefore 360 by 8, right? The answer will be, the step angle will be 45 degree. Okay, by the step angle of 45 degree the rotor gets rotates in this structure. If we are having 4 stator poles and 2 rotor poles, means the step angle will be 45 degree. The rotor will rotates in the angle of 45 degree of the step angle. Okay, so here we are having different types of stepper motor. Permanent stepper motor, then variable reluctance stepper motor, and hybrid stepper motor. Three types we are having: permanent magnet stepper motor, variable reluctance stepper motor, and hybrid stepper motor. Okay, so the working principle of all these three stepper motor will be almost same, and the construction is also the same with small difference. Okay, first we will see the permanent magnet stepper motor. So here, as I said, this type of motor is called a two-phase, two-pole permanent magnet stepper motor. So here permanent magnet stepper motor means we will be having permanent magnet in rotor. Okay, in this construction we are having the permanent magnet with two poles. Okay, so here consider the 4 stator poles A1, A2, B1 and B2. Inside the stator we are having rotor. In rotor the permanent magnet is fixed here. Okay, so here in this stepper motor the stator is constructed with silicon steel and it is varnished. This produces less eddy current and hysteresis loss. Okay, this type of stepper motor will produce less eddy current and hysteresis loss. And here the rotor is a smooth cylindrical poles. Okay, so here we are considering 4 stator poles and 2 rotor poles, and these stator poles are winded. All the stator poles are winded with the coils. Then these number of windings will be splitted into 2 identical halves. Okay, winding A is splitted into 2 halves, that is A1 and A2. Then winding B is splitted into 2 halves, that is B1 and B2. Okay, under A1 and A2 the switches are Q1, Q2, Q3 and Q4. So what will be the switches in B1 and B2? Q5 to Q8. Okay. So here where we will see the working principle of this permanent magnet stepper motor. As I said, we are having 4 stator poles A1, A2, B1, B2. Okay. Here the step angle will be 45 degree. Okay. So here the stator poles will be winded with the coils, right? At a particular time, the supply is given to any one poles. Okay, so when we are giving supply to any one poles, the flux linkage is created and it will makes the rotor to rotate. Okay, first of all, when we are giving supply to A1, okay, when we give supply to A1, this A1 is get energized, the coil in the A1 get energized and it attracts the rotor, since rotor is having permanent magnet. Okay, we all know the magnet attracts the opposite poles attracts each other, right? So here when this A1 is energized, if here we will be having north pole, and for rotor we are having permanent magnet south pole and north pole. When A1 is energized, the opposite pole of this side, that is south pole of the rotor, get attracts with the A1, with the stator of A1. Okay, with the angle, it moves in the angle of 45 degree. Okay, then in the same case, when B1 is energized, again this rotor rotates with the angle of 45 degree and it attracts with the stator poles. Again, when this side get energized, A2 to A1, when it gets energized, again it rotates with the angle of 45 degree and this rotor get attracts with this stator poles. Okay, then again when this switch get energized, this rotor get attracts with this B pole and in the angle of 45 degree. Likewise, this stepper motor will be rotated in the form of step angle. Okay, this is the working principle of all the stepper motors. Okay, in the sense of permanent magnet stepper motor, rotor is fixed with the permanent magnet. Can you understand? So here in permanent magnet stepper motor, it cannot be constructed in the form of small size. There will not be any small size motor, and also small steps are not possible. That small step angles are not possible in this type of stepper motor. Okay, the next one is variable reluctance stepper motor. So in variable reluctance stepper motor, almost the same as that of permanent magnet stepper motor only. So here also we are having stator and rotor. The stator windings are wound on the stator poles. Okay, and rotor carries no windings. Okay, and here the rotor poles are constructed with the ferromagnetic material. Okay, this motor is called variable reluctance motor, because the reluctance of this motor will be low reluctance path will be available in variable reluctance stepper motor. The low variable reluctance path, this stepper motor gets operated, that is the rotor gets operated or rotated in the form of particular step angle, that is variable reluctance stepper motor. And the third one is hybrid stepper motor. So hybrid means combination of any two features, right? So here hybrid stepper motor means Already we have seen permanent stepper motor and the variable reluctance stepper motor. So hybrid stepper motor means it combines the features of variable reluctance stepper motor and permanent magnet stepper motor. Okay, this is the construction of hybrid stepper motor. So here in this type of hybrid stepper motor, as usual we are having stator and rotor. Okay, so here this is a rotor, this is shaft, and the rotor is here. This is stator laminations, stator is here, and this is yoke. Yoke means it gives the mechanical support to the stepper motor. So here as I said, it combines the features of variable reluctance stepper motor and permanent magnet stepper motor. Here the stator will be electromagnetically magnetized and rotor will be axially magnetized with permanent magnet. Okay, so here in this type of construction we are having the stator teeth is 40, rotor teeth will be 50. So the step angle will be 1.8 degree. Here the stator poles will be 8 poles with 8 number of stator poles. This type of hybrid stepper motor is constructed. Okay, so this stator poles, this 8 stator poles divided into 2 phases. That is, phase A will be having 1, 3, 5, 7 switch, and phase B will be having 2, 4, 6, 8 poles, even numbers. Okay, so here this is the construction and the working principle will be almost same, and here the stator will be electromagnetically magnetized and rotor will be axially magnetized with permanent magnet. Okay, and the step angle for this construction will be 1.8 degree. With the step angle of 1.8 degree, the rotor gets rotated in this type of stepper motor. Okay, and these type of stepper motors will be used in quartz watches, floppy disk drives, X-ray machines, aerospace, industrial application. Okay, and also in robotic system also it will be useful. For example, in robots, the hands of the robots will be moved in the form of some step angle, right? Particular step angle, the hands and legs will be moved forward. Okay, and also in industries, in juice companies, if we are considering, for particular rotation, for particular step angle, it gets rotated for the multi-purpose. Okay, first it will fill the liquid in the bottle, then for particular in step angle rotation it will move, and then the bottle will be closed. Okay, so likewise it rotates and fill the you do the multi-purpose task. Okay, so that will also one of the stepper motor applications. Okay, hope you all understand this video. Thank you.